Good morning, all. My name is Uma Devi. My topic is square roots and cube roots. In this topic, learning objectives are students able to calculate square and cube numbers with and without calculator. Students able to calculate square and cube roots with and without calculator. And students able to calculate any power with a calculator. These are the learning objectives in this topic. So, we are going to find the square roots and cube roots using various different methods in this topic. Okay. Before going that, we are going to learn about what are square numbers and cube numbers. Let's start the topic with perfect square. If I express a rational number which can be expressed as square of another rational number is called perfect square. So, a perfect square is a rational number which can be expressed as square of another rational number. Let's see with example of perfect square and what number formed perfect square. For example, I have 4. I can write this 2 into 2, that is equal to 2 square. So 4 is 4 is equal to 2 square. So 4 is perfect square. Next example. 9 is equal to 3 square. So 9 is a perfect square. Next 16. 16 is equal to 4 square. Okay, 16 is also perfect square. Next example 1.44. 1.44 can be written as 1.2 whole square. Okay, 1.44 is also a perfect square. Next example 9 by 16. 9 by 16 is written as 3 by 4 into 3 by 4, that means 3 by 4 whole square. Okay, 9 by 16 is also perfect square. So there are various example of perfect squares. Okay children, did you understood? Perfect square means a number which can be expressed as square of another number. Which another number, children? A rational number. A rational number which can be expressed as square of another rational number is called perfect square. Here 4, 9, 16, 1.44, 9 by 16, these are all rational numbers. Okay children? Okay, good. Children, see the slide and observe the perfect square in the given table. 1, 4, 9, 16, 25, 36, 49, 64, 81. These are all perfect square. So this is the definition of perfect squares. Okay? Okay children? The next definition is square number. Square numbers are defined is same definition, but instead of rational number I have an integer. An integer which can be expressed as square of another integer is called square number. So let's some example of square numbers. I take 4. This can be written as 2 square. 4 is square number. Okay, therefore 4 is a square number. And 4 is also perfect square. Okay, next example is 49. This can be written as 7 square. Therefore 49 is square number and 49 is also perfect square. Next example 289. 289 is equal to 17 square. 289 is also square number, at the same time perfect square also. Okay children, see the slide. Square numbers are here: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225 are all square numbers. Okay. Next, difference between perfect square and square number. See the slide children. In this perfect squares are 1, 4, 16, 1.44, 0.01, etc. But square numbers are 1, 4, 9, 16, 36, so on. All square numbers are perfect squares, but all perfect square need not be square numbers. Okay children? All square numbers are perfect squares, but all perfect squares need not be square numbers. Example: 0.01 is perfect square. 0.01 can be written as 0.1 whole square. But this is not a square number because 0.01 is rational number. Okay children? According to the square number definition, an integer which can be expressed as square of another integer. Okay children? 0.01 is a rational number, not a integer. Okay children? And one more important note here, 7. I can express 7 is a square of another number. See the slide children. 7 is root 7 into root 7 equal to root 7 whole square. But 7 is neither a square number nor perfect square. So 7 is not a square number and also is not a perfect square. Since the definition of perfect square is a rational number being a perfect square and an integer being a square number. Root 7 is like not a rational number and not a integer. It is an irrational number. So this kind of numbers which can be expressed square of roots. Okay children? We have seen two basic definition of perfect squares and square numbers. We should be able to understand children. So the question about square number between 1 to 100. See the slide children. Here multiplication table are there. 1 into 1, 1 square. 2 into 2, 2 square equal to 4. 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100. Okay children? But I don't take 1 and 100 because I want all squares numbers between 1 and 100. So the square numbers 1 and 100 are 4, 9, 16, 25, 36, 49, 64, 81. These are all 1, 2, 3, 4, 5, 6, 7, 8. 8 square numbers lie between 1 and 100. Let's next question. Find about perfect squares in 1 and 100. Going with similar example as in the previous case, where we have found the square numbers lie between 1 and 100. Finding that perfect squares between 1 and 100 would not be easy because square numbers are square of an integer. There are limited number of integers between 1 to 100. But perfect squares are the square of a rational number. There are unlimited number of rational numbers between 1 to 100. So square of any rational number would give me the other rational number lie between. So it is difficult to identify rational numbers which can be squared between there. So answer is infinitely. Infinitely many perfect squares lie between 1 to 100. The reason being that there exist infinitely many rational numbers between 1 to 100. The reason being that exist infinitely many rational numbers between 1 to 100. This being the reason. You have infinitely many perfect squares between 1 to 100, but you have limited number of square numbers in 1 to 100.